ever pull a part from a mold, expecting absolute perfection, and then, you see a flaw? It is one of the most frustrating things in composite molding, right? Well, what if I told you there's a simple framework to turn those defects into perfect parts pretty much every single time? Let's dive in.
I mean, this is what we're all shooting for, a flawless part, right out of the tool, ready to go. But the reality? Well, it's often a fight against all kinds of defects that can totally wreck your production schedule and, let's be honest, your bottom line.
First up, one you've probably seen, the dreaded blister. It's that bubble on the surface, a dead giveaway that trapped gas has literally forced the layers of your composite apart from the inside. Or how about this one? Crazing. You see this web of superfine hairline cracks? That's your part screaming that it's under some serious stress, either from being handled wrong or from thermal shock. And then you've got chips. Oh, these are infuriating. Those little missing chunks that just love to show up right on the edge, turning what was a perfect part into a piece of scrap.
So yeah, these defects can feel totally random, almost impossible to pin down. How do you stop firefighting and start actually diagnosing the real root cause so you can fix it for good?
Well, the answer comes down to a really simple but incredibly powerful framework. Seriously, this is a universal method you can use to diagnose any molding defect you come across.
And here's the core idea, the whole secret sauce. No matter what the problem looks like on the surface, you can always trace it back to one of three fundamental areas.
And those three pillars are your material, your process, and your tooling. That's it. Is the problem with the composite itself? Is it the way you're molding it, your temps, your speeds, your pressures, or is it the equipment you're using? Every single defect fits into one of these buckets. If you master these three, you can solve just about anything. All right, let's put this framework to the test. We're going to start with those common, really visible flaws, the ones you see on a part's surface, and see how material, process, and tooling helps us nail down the fix. Okay, let's circle back to blisters. Remember, these are all about trapped gases under pressure. So that gas has to come from somewhere, right? And something has to be trapping it. Our framework is going to help us figure out exactly what's going on. So let's start with process. A classic mistake here is closing the press way too fast. You slam it shut and you trap air in the laminate before it has a chance to get out. Bam, you've got a blister. The fix is usually pretty simple. Just slow down the press closure and give that air time to escape. But what if your process is dialed in perfectly? Well, then the problem could be your material. If your raw material is contaminated or has too much moisture, it's going to turn into gas under all that heat and pressure. The solution here happens before you even get to the mold. Start with clean, properly conditioned material.
And finally, let's look at tooling. You could have perfect material and a perfect process, but if your mold's shear edge is too tight, you've basically blocked all the exits. The air has nowhere to go. So the solution is to make sure your tooling is clean and has the proper clearance for that air to bleed out.
All right, let's tackle another one, crazing. Now, these hairline cracks aren't about trapped gas. They're all about stress. We're talking either mechanical stress or thermal stress. And here's a huge insight. Sometimes the problem isn't even in the molding cycle itself. It's what happens after. Rough handling or a really violent ejection system can put a ton of stress on a brand new part, causing those cracks. This is a classic process issue, and you fix it with better training and a gentler ejection. Okay, so we've talked about the surface level stuff. Now let's go a little deeper and look at structural flaws. These are the defects that can actually compromise the strength and integrity of the entire part. Which brings us to chips, that annoying damage right on the edge of a part. And yeah, maybe they're repairable, but they point to a breakdown somewhere else in your production line that you need to fix.
And once again, the culprit is so often found in the process. Chips are frequently caused by poor handling after the part is molded. Stacking parts on top of each other with no protection? That's just asking for edge damage. The fix is procedural. Use proper racks and dedicated transfer lines.
This also puts a huge spotlight on tooling maintenance. If your mold has a damaged edge or there's built-up flash on the shear, guess what? It's going to transfer that defect to every single part you make. The solution here is all about prevention. Keep your molds clean and in good repair.
Because if you get these fundamentals wrong, you risk the absolute worst-case scenario, a fracture. This isn't a surface crack. This is a complete structural failure, a crack that goes all the way through the part, making it totally useless. So, we've seen the framework in action. We've looked at specific defects. But what are the big picture principles we can pull from all this? What are the key takeaways?
Well, let's just boil it all down to the golden rules. And you'll see they all connect right back to our framework. Maintain your molds, that's tooling. Start with clean material, that's material. Control your variables, handle parts with care, optimize your flow and pressure, and for goodness sake, always give trapped air an escape route. And that is all process.
If you follow these rules, you can solve just about any issue that comes your way. Which, leads me to a final question for you. What's the one molding defect that just has you completely stumped? Drop in the comments below. Let's talk about it.
By the way, this whole explainer was based on the amazing troubleshooting guide from ID Composites International. It's an incredible resource if you're in this field. Thanks so much for watching, and we'll see you in the next one.